Hello, and welcome to our lesson on ordering decimals. Today, we'll explore an important mathematical skill that will help you understand numbers more deeply and enable you to solve a variety of problems more effectively. In this lesson, we'll build on our intuitive understanding of decimals and focus on the technique for ordering them. Here's what we will cover. We'll start by reviewing the structure of decimals and how they are composed of digits representing different place values. Then we'll introduce a step-by-step method to compare and order decimals. Finally, we'll go through some practical examples to apply this new knowledge and reinforce our understanding. In our previous lessons, we've laid a foundation by developing an intuitive understanding of what decimals are. We have also learned to recognize that decimals represent parts of a whole and understanding their notation, and developed our understanding of placing decimals on the number line. With this foundation, we can now focus on ordering decimals. This technique is vital for solving problems that involve comparing sizes, quantities, and measurements accurately. For instance, consider a scenario where we need to rank the scores of different students in a test. Knowing how to order decimals correctly allows us to determine the correct rankings and make informed decisions. Let's get started. First, let's clarify a common misconception. Unlike with whole numbers or integers, seeing more digits after the decimal point does not necessarily mean a number is larger. For example, 0.50748 is not larger than 0.52. This might seem counterintuitive at first, which is why we need a reliable method to compare these numbers correctly. To compare and order decimals effectively, we can use a comparison table that aligns the decimal points. This helps us to see the values more clearly. Write out the whole numbers in their appropriate columns, then write out the decimal numbers in their appropriate columns, tenths, hundredths, thousandths, etc. If one number has fewer decimal places than another, add zeros to make up the difference. This doesn't change the value of the number, but allows us to compare them easily. Now compare the numbers digit by digit from left to right. In this example, the whole number part, 0, is the same for both. The tenths place, 5, is also the same for both. However, the hundredths place differs, 0 in 0.50748 and 2 in 0.52. Clearly, 2 is greater than 0, so 0.52 is larger than 0.50748. As you become more familiar with this technique, you might not need to set up a comparison table every time. With practice, you can start to identify which decimal is larger visually. However, if there's ever any uncertainty, especially when dealing with more challenging comparisons, don't hesitate to fall back on the comparison table method. It provides a clear and systematic approach to ordering decimals correctly. Let's proceed with some practical examples to solidify this understanding. Consider the decimals 3.45 and 3.5. To compare these, we align their decimal points. When we look at the digits from left to right, we see that both numbers have the same whole number part, 3. In the tenths place, both have 4 and 5 respectively. Since 4 is less than 5, we know that 3.45 is less than 3.5. Let's compare 2.456, 2.46, and 2.459. Aligning the decimal points, we get this. Looking from left to right, all have the same whole number, 2, and same tenth digit, 4. In the hundredths place, there are 5, 6, and 5. So we can see that 2.460 is larger than the other two numbers. We now focus on the thousandths place. For 2.456, the thousandths digit is 6. For 2.459, the thousandths digit is 9. So 2.459 is larger than 2.456. Thus we can conclude 2.456 is less than 2.459, which is less than 2.46. Consider the decimals 4.5, 4.05, and 4.505. Align the decimal points in a comparison table. Now, reading this from left to right, we can see that all have the same whole number, 4. In the tenths place, we can see 5, 0, and 5 respectively. Since 0 is less than 5, 4.05 is the smallest. When comparing 4.5 and 4.505, there is the same value of 0 in the hundredths place. In the thousandths place, there is 0 and 5. Since 0 is less than 5, 4.500 is less than 4.505. So 4.05 is less than 4.500, comma, which is less than 4.505. By practicing these examples, you'll get comfortable with comparing and ordering decimals, an essential skill for many areas in mathematics and real-world problems. In today's lesson, we focused on the essential skill of ordering decimals. We began by reviewing the structure of decimals, emphasizing that more digits after the decimal point do not necessarily indicate a larger number. To compare and order decimals accurately, we introduced the technique of using a comparison table. By aligning the decimal points and equalizing the number of decimal places, adding zeros if necessary, we can compare digits systematically from left to right. As you become more comfortable with this method, you may be able to compare decimals without always needing a table. By mastering this technique, you'll be better equipped to handle problems involving the accurate ordering of decimal numbers, enhancing your mathematical proficiency. Watch the rest of the GCSE Maths course at Sophos Education.